You've probably heard Billie Eilish's song about it, but what actually is this black hole? And could it really swallow the Milky Way? It's me and you're watching this channel. Today we're answering the extraordinary. Could this one black hole devour our galaxy? Black holes are regions in space where gravity is so intense that nothing can escape their grasp, not even light. Their defining property is an inescapable boundary called the event horizon. Once something crosses the event horizon, there's no turning back. Not only can nothing escape the clutches of a black hole, not even light, but it also can't communicate with the outside universe. Information lost to a black hole is truly lost forever. The size of a black hole is known as its mass. The bigger the mass, the bigger the radius or diameter of the black hole, and the larger its event horizon. Black holes come in many sizes. Some are only a few times heavier than our sun. Others can be millions or even billions of times more massive than our star. These colossal ones reside at the centers of most galaxies, including our Milky Way. Ours is known as Sagittarius, a star, with a mass around 4 million times that of the Sun. Sagittarius, a star, isn't particularly big for a supermassive black hole. If it were any larger, the orbits of the stars closest to it would take them beyond the reach of the Sun's influence. So while it might seem enormous, it's just small enough to keep everything in check. But there are black holes out there that are much, much bigger than even Sagittarius, a star. One such black hole goes by the uninspired name of Phoenix, and it resides in the center of the M87 galaxy, which lies 55 million light-years away from Earth. With a mass over 65 billion times that of our Sun, Phoenix dwarfs Sagittarius, a star. To put into perspective, if our Sun were the size of a soccer ball, Phoenix would be equivalent to a bowling ball. And that's just the size of its event horizon. The actual diameter of Phoenix is thought to stretch between 440 and 540 billion kilometers across. That's about as wide as 193,000 American football fields laid end to end. But while Phoenix may be huge, its location is fortunate. If it were residing in the galactic core instead of M87, it would have been a very different story. Its enormous gravitational pull would have disrupted the entire galaxy, tearing apart star clusters and flinging them out into intergalactic space. Instead, it happily sits in the center of its home galaxy, surrounded by a hot plasma disk called an accretion disk, which is powered by material it devours. So just how do black holes feed? When a star ventures too close to a black hole, it gets ripped apart by the extreme gravitational forces. This process, known as spaghettification, stretches the star into a long, thin stream of gas and dust before it's consumed by the black hole. But not all objects need to get so close. Gravity decreases with distance. So as a star approaches a black hole, its gravitational pull increases until it becomes stronger than the star's own gravity. At this point, the star begins to accelerate towards the black hole. The closer it gets, the faster it moves. Eventually, it reaches a point of no return, the event horizon, and it falls into the black hole. But it's not just stars that can fall into a black hole. Anything that gets too close, from gas and dust to even light, will be pulled in. And the material that forms the accretion disk doesn't have to be ripped apart before it's devoured. It simply spirals into the black hole, adding to its mass and increasing the size of its event horizon. Now that we know how a black hole grows, let's turn our attention back to Phoenix. With a mass over 65 billion times that of our Sun, Phoenix must have consumed a lot of material to reach such a colossal size. Given its proximity to Earth, researchers have had the opportunity to observe its feeding habits. What they've found is truly astounding. In 2022, a team of astronomers led by Lemaire DeRose at the Institute for Advanced Study in Princeton, New Jersey, published a paper in the journal Astronomy and Astrophysics. They estimated the mass of the supermassive black hole at the center of M87. Based on observations made by the Event Horizon Telescope collaboration, the collaboration used 7 radio telescopes around the globe to create one Earth-sized telescope and captured the first image of an actual black hole in 2017. The image showed a bright ring of light surrounding a dark central region, the black hole's event horizon. By analyzing the motion of material in the accretion disk, the team was able to estimate the black hole's mass. They found that Phoenix has a mass of 66.5 billion solar masses. But wait, this is where things get interesting. While observing the supermassive black hole, astronomers noticed something peculiar. They observed a luminous object moving in a peculiar way. It seemed to disappear and then reappear in a different location. What's going on here? Well, it turns out that this strange behavior is due to the immense gravitational field of the black hole. As the object approached the event horizon, it experienced a phenomenon known as gravitational lensing. This happens when the gravity of a massive object distorts the fabric of space-time around it, bending and magnifying the light from distant objects behind it. In this case, the black hole's gravity distorted the light from the quasar, making it appear as a ring. As the object continued to orbit the black hole, the gravitational lensing effect changed, causing the quasar to seemingly disappear and reappear in different locations. But there's another explanation for this mysterious disappearance. You see, black holes don't just have an event horizon, they also have a singularity at their center. The singularity is a region of infinite density where all the matter that falls into a black hole is crushed. We don't know exactly what happens at the singularity because it's impossible to observe it directly. But we do know that it's the point of no return for anything that falls into a black hole. When something crosses the event horizon, it can never escape. Not even light can escape the clutches of a black hole. And that means that once the quasar crossed the event horizon, it was gone forever. We can never see it again. So which explanation is correct? Well, it's likely that both are at play. The quasar was indeed affected by gravitational lensing as it approached the event horizon. But it was also ultimately pulled into the singularity and destroyed. So could this one black hole devour the Milky Way? The answer is no. Despite its enormous size, Phoenix is located 55 million light-years away from Earth. This vast distance prevents any significant gravitational interaction between our two galaxies. And even if Phoenix were located in our galactic neighborhood, it wouldn't pose a threat to the Milky Way. The reason why? Our galaxy is held together by the gravitational pull of all the stars within it. The supermassive black hole at its center plays a crucial role in keeping everything in balance. If the black hole were to disappear, the outermost stars would likely drift away, but the majority of the galaxy would remain intact. There's plenty of room for a supermassive black hole like Phoenix in the Milky Way. Just ask Sagittarius, a star. Our galaxy has enough room for 2 supermassive black holes. It would take a black hole roughly the size of Phoenix to disrupt the delicate balance of our galaxy. And even then, it would take millions of years for the black hole to consume enough mass to grow large enough to threaten our solar system. So while a supermassive black hole like Phoenix might seem terrifying, it's important to remember that it's very far away and not a threat to our existence. In fact, it's just one of many fascinating objects in the vast universe that we're lucky enough to observe. If you enjoyed this episode, I highly recommend checking out our previous episodes on black holes. We've covered everything from the smallest stellar black holes to the largest supermassive ones. You will learn about the amazing discoveries made by astronomers and the cutting edge technology used to study these mysterious objects. Thank you so much for tuning in. Hope you learned something new and exciting about our universe. If you want to continue learning about amazing scientific discoveries, be sure to subscribe to the channel. Thanks for watching, and I'll see you next time.